Hello, everybody. One of your colleagues asked me a question which I think might be quite basic, and I do not cover this on next level, but I thought it might be useful because probably some of you are going through the same questions. And also, Jobsmith and my work constantly mentions functional families, functional groups. So I thought this might be useful for some of you to refresh or understand, and some of you know much more about chemistry. So also it would be nice to contribute to the community. If you have something to add to my video or something you'd like to share with the community uh, about this, please feel free to do so and add to my video. So the question was, what is this chemical structure? And it's methyl eugenol, and this is the formula for it. And the chemical structure is without these blue lines, but I added them because the next question is if it's possible to draw the carbons and hydrogens on the structure. Well, the carbons I didn't do because it would just take forever, and we will go through it, so I will explain it. So first of all, I want to show you where you can find this on Dropsmith. So if you go on Dropsmith and you filter methyl eugenol, you can find oils that have it. So I can already give you some clues. So let me do that again. Let me erase. So you go to Advanced Filter, Chemical Groups and Components, and then you search for methyl eugenol, and here it is. So I'll put anything over 1%. And here I would like to choose nutmeg. So you can, if you don't know, you can expand all and then search for it like in the Finder. Or as I know it's in the ethers, so you can look straight to ethers. Let me collapse it. Or you can just go straight to ethers and find which one it is and then get the properties and how to use it. So that will tell you a little bit more about the specific chemical component. And as you see, it's an ether, but an aromatic ether. You will see that when we classified the functional groups in Dropsmith, this one, see, you can find also it's monoterpene, sesquiterpene, aromatic, and we have more classifications. So you will not only find an aromatic ether, you will find an aromatic alcohol or ketone or whatever. And what does that mean? That means that the component has this benzene ring. So here we have actually an ether and a phenol, if we are to be more exact. So let's come back to methyl eugenol and the question itself. So the question is it possible to draw carbons and hydrogens on the structure? Because I'm guessing from the studies you're doing elsewhere, you couldn't really figure out this bit of information. So let me try and get this bigger for you, for it to be easier, and I'd like to keep the number. So first of all, let's start with the oxygens, and this is what defines the ether group actually. An ether is an organic compound in which two hydrocarbons are bonded to the same oxygen atom. So you see here we have the two oxygens. Actually, you just need one, but this one has a double. So an oxygen is bonded to two hydrocarbon atoms. So here and here. So one oxygen has two carbons on each side. And here you have it again. So that's what defines an ether as a functional group. And so there's your question for the oxygens, but I guess you knew that. 1, 2. That's the number 2. So let's go to hydrogens. Okay. So this could be easier to count because right here on the right you see that there's 3 hydrogens here and 3 hydrogens below. So that's 3 plus 3 is 6, and on the left side you see that there's 2 more. So 6 plus 2 is 8. So 3 hydrogens here, 3 here, that's 6 plus 2 on this side on the left, that's 8. And so we need just a few more to come to 14. So I found them here. 9, 10, 11, 12, 13, 14. And let me explain to you how I got to that number. And I will make it a little bit bigger. I apologize. Okay, so the reason I didn't draw the carbons because they are on every one of these joints here. Okay, so there's tons of them. That's first thing to look at. And we are looking at the bonds. So a carbon likes to be connected to four different molecules. So each of these bonds actually represents that. So here you have 1, 2, 3, and you're missing a fourth. Then you will find a hydrogen there. So that's why this one's here. So here you have another one. 1, 2, so you're missing 2 more. 3, 4. That's why we have 2 hydrogens here. And here you have 1, 2, 3, and the fourth because of the double bond here. So this one doesn't need it. Okay? So 1, 2, 3, 4. Here's your another hydrogen. 1, 2, 3, 4. We added one here. And 1, 2, 3, 4. I hope that makes sense. It's a very quick chemistry lesson, but you can find this on internet very simply. I'm just trying to answer the question as straightforward as possible. So these are the hydrogens. So let's look at them again. So you have 3 on the right here and 3 at the bottom right. That's 6 hydrogens. 8 plus 2 on the left. 9, 10, 11, 12, 13, 14. So that adds up. So here we have so far. We're going from behind. So let's find those 11 carbons. And then we are actually through. Yoo-hoo! So here you have one here, which is attached to hydrogens. 1, 2, 3, 4. Okay? So 1 carbon, 2 carbons, 3, 4, 5, 6, 7, 8, 9, 10, 11. Voila! See? 11. So everywhere you have this little corner, that's where your carbon is. Let me show you one more time. So 1 here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so I hope that answers your question. And yeah, good luck. Let me know what you think of the video. Was this helpful? Was it useful? And good luck on your journey. I will see you on my next video. Have a lovely day, everybody. Goodbye.